Uniform circular motion. When a particle moves with a constant speed in a circular path, its motion is said to be uniform circular motion. In this type of a motion, a particle travels equal distance along the circular path in equal interval of time. So, the speed of a particle will be uniform, but the direction of the motion of the particle changes at each point of the circular path. If the continuous change in the direction of the motion shows the velocity of the particle is non-uniform, that means variable, the motion is accelerated. Now if you see in the picture, we can see clearly that a particle moving in a circular path in a horizontal plane with a uniform speed in an anticlockwise direction. Here the force we apply means the direction of the motion. Here it takes every quarter, that means t by 4 in one direction, again t by 4 in another direction, t by 4 in another direction, and last will be the t by 4, means here the circle into the 4 parts. The total time will be the time taken by the particle to complete one round or a one circular path. Here the speed of the particle is constant, but the direction of the motion of the particle is different at different points of the circular path. At any point the direction of the motion is along the tangent we can see the drawn at the circular path. Here the direction of the motion of the particle, if we consider from the right upside, it will be at the north, and next to the half of the circle towards the south, then third quarter, like that it will take to the north, west, south and east. The particle in a circular path, the motion is variable, or the circular motion will be accelerated even though the speed of the particle is uniform. Here what is linear motion? In linear motion, you can see in the left side picture, linear means straight. Here the speed and velocity both are constant and acceleration is zero. Uniform linear motion is unaccelerated motion, while a uniform circular motion, the velocity is variable although the speed is uniform, so it is an accelerated motion. Next, here centripetal and centrifugal force. Here we know that force is needed to change the direction of the motion of a particle, that is to produce acceleration. A particle moving in a circular path continuously changes its direction of motion at each point of its path. The change in direction of motion cannot be brought without a force. Thus, the motion in a circular path is possible only under the influence of a force which we call as a centripetal force. Here at each point, the circular path, the force is directed towards the center. That means the direction of the force and also of the acceleration changes at each point of the circular path, but its magnitude will remain same and the acceleration is variable. Hence, for a body moving in a circular path, a force is needed which acts as a centripetal force. Thus, centripetal force is the force acting on the body moving in a circular path in a direction towards the center of the circular path. Example, in an atom, an electron moves around the nucleus in a circular path, which requires centripetal force to obtain the electrostatic force of attraction on the negatively charged electron by the positively charged nucleus. Number 2 example, a planet moves around the sun is an elliptical orbit, which the gravitational force of attraction on the planet by the sun provides a necessary centripetal force. Moon moves around the earth in an elliptical path. Again, the gravitational force of attraction on the moon by the earth provides the required centripetal force. That means acting towards the center. Number 4, when a stone tied at the end of a string is whirled in a circular path holding its end in the hand, you can see the tension in the string provides a centripetal force. In the absence of this force, the tension stone will not move to the circular path. In this all example, we can say body moves in a circular path with a uniform speed under the influence of centripetal force, and it is a force. Here centripetal force is a force, that means example, the car also moving towards the center and the force is acting towards the center, we call as a centripetal force. Now centrifugal force. Here a force assumed moving means to be acting on the body in a direction away from the center of the circular path is called centrifugal force. Here, the centrifugal force is in a direction opposite to the direction of the centripetal force. Its magnitude is same as that of the centripetal force, but the centrifugal force is not the force of reaction of the centripetal force, remember, because action and the reaction do not act on the same body. It is not a real force. That is the reason centripetal and centrifugal force are not equal and opposite. They are different because they are acting on the different body. Therefore, centrifugal force is the fictitious force assumed by an observer moving in a circular path along with the body. Here, to understand the centrifugal force correctly, here we take up an example. Consider we are having a ball tied at one end of the string. The other end of the which is tied at the center of the merry-go-round, means you know merry-go-round, the game which will be there like a disc, and the handles will be fixed. Now we are considering such example. Here we are tying a stone where the axle at the center is fixed, a string with a stone. Initially, when the platform of a merry-go-round is not moving at rest, the ball is seen stationary and the string will be loose and the ball will be hanging with the help of a string because it will be loose. As the platform starts moving, the ball rolls towards the edge of the merry-go-round and it will become the tension and tied due to the tension force developed in it. So here we consider two people here which is standing at the ground, that we call as M, and one person is standing on the platform of the merry-go-round and we will take up as a. The person standing on the ground M, the ball moves in a circular path because the tension in the string provides a centripetal force needed of the circular motion. Here this M, if you see, we see that the string is moving in a circular path, we observe. On the other hand, if we see a person who is standing on the platform of the merry-go-round, here the two forces will be acting on the ball. To understand, we have to see in that way. The tension of the string towards the center merry-go-round and another centrifugal force is acting away from the ground. Here the two above forces are equal and opposite. Therefore, the net forces on the ball is zero. Hence, it is always remains stationary in front of him. Thus, a person standing on the rotating ground platform will observe the two centrifugal along with the force of tension in the string.